meeting is being recorded.
Hello, everyone, and welcome to the April 27th edition of the SIG-Network meeting. Just a reminder for everyone, as usual, that this meeting is governed by the Kubernetes Code of Conduct, which boils down to please be nice to one another. So please do be nice to one another. We have a few things on the agenda today. It looks like not too many, so it's an open agenda. If you do have something that you want to bring up, please do feel free to try to add it to the agenda, and we will see if we can get to it this time, if not next time. With that, we usually jump right into triage, but I think maybe we'll hit the agenda. Unless somebody has an objection, we'll just hit the agenda and then follow up with triage. So let me go ahead and...
I'll say there's a couple of issues on triage that look like net new bugs that may have been introduced in 27. So
okay, maybe we'll start with that then.
Well, there's two that are both flagged as IPVS, I think, that it would be useful if somebody from IPVS could go look at. They're both Kube proxy and IPVS, I think. And then there's one about IPAM allocation, which I just tagged Sarvesh and Antonio on. The others are older. So there's really only three to look at.
Okay. So yeah, let's start with it sounds like let's just go with what we got in the agenda so far, and then we'll follow up with triage then. But if anybody could jump on those in particular, IPVS and so forth, we'd appreciate it. Can you see my doc? Is that working?
Yep.
All right, then let's get started. Tim, you wanted to talk about KEP's dashboard updates?
Yeah, give me a second while I move this to another screen. I can share. Where did it go? There it is. I'm going to share the KEPs. Oh, can you share me?
Yeah, sure.
Wrong button. Share.
You should be good now.
Yep. What's this window called? SIG-Network KEPs. How's that? Can you see it? Yes. All right. Let's do the 27's out. Congratulations, everybody. Let's run through KEPs and see what we need to touch in terms of moving between columns and in terms of next milestoning. So did we remove any gates this time? We removed dual stack, right? Oh, this is already in the column. Sorry, I'm in the wrong column. Did we remove, traffic policies 28, 27, gRPC probe. Did that go GA? There. Did we remove the gate? Ugh. Anybody know?
You mean remove the gate at all?
Yes. It looked. I think it was flagged. It's impossible for me to tell here if we removed the gate or if we just moved it to GA. Who knows what this deal was with gRPC? I forget.
I need to go through this code later, so I can take an action and do a cleanup.
I can just look at the features real quick.
I usually go to the Git log and see.
Yeah, gRPC. Okay, it went GA in 27, so that one's already been touched. I made the mistake of touching a few before.
Yeah, I thought we already did this like 2 meetings ago or something.
We did some of it, but we didn't touch the ones that need to be updated now in 29 or 28. That's right. Thank you, Dan. Let me close these because not interesting right now. Okay, so gRPC went GA in 27, so we're going to set the next touch for 29, right? So let's watch this. How do I add a new milestone? Can't I? Did I lose that ability? Great, add a new
Looks
milestone.
like it's at the bottom there.
There we go.
So the code says to remove in 129, right?
Yep. So now I mark it. I mark it as 129, and we know that the next time we touch it, will be 129. This is 28, this is 28, this is 28. Cool. 28, 28, 27. This, we want a GA in 28, hopefully, right? This is the service controller stuff. IP tables chain ownership. Dan, that ready to GA in 28, you think?
Let's hold off deciding.
Okay.
I discovered that cryo was doing things that would obscure other components' bugs, and so I'm suddenly slightly less confident that everything is working.
Okay, I'm gonna tag it for 28 so that we can reevaluate it.
Okay.
Otherwise, I'll just lose track of it. Unfortunately, we get one milestone, so there's no good way to indicate notes here except adding notes. But,
Yeah, we could just bump it back off 128 if we decide to.
That's
later,
right.
I guess.
Okay.
By the way, for any of these that we're milestoning for 28, we should probably have somebody look and see if there's like a needs docs. Because if the code is ready to go, it would be a shame if we can't get it in just because we don't get the other ancillary bits ready.
Okay. Dual stack IPs, Dan?
I should simplify the KEP, and yeah, we can go to beta in 128.
All right. Multi-service CIDR. Antonio, I know we have a big hot discussion on this. I'm gonna mark it for 28 so that we can rediscuss. What are you thinking about 28? Like probability?
The problem is not in the implementation. The problem is on the decision of what do we do with the service CIDR and the cluster CIDR, because right now we are on hold on that, on this big discussion. But for implementation, there is no problem. I already have the code.
Okay. And node port reserve ranges, did that beta in
That
20?
is-
No. Okay.
That's an easy. So if you can ping the person, but I don't think that he attends. But that's an easy feature to promote.
Okay. Yeah, alpha. Okay. I'm just cross-checking everything, make sure there's no more 27s left. Pre-alpha network policy status. What did we decide with that? Did we kill it?
We did, although the PR to remove it from tree has not merged yet. So
Okay. I'll look at that, but I'm going to move it over to, can I move it all the way over? No. How do I move it? I can't see both at the same time. I'm going to do this. Nope, I grabbed the wrong one. All right, I'll do that one later. Load balancer behavior, that one's still on me. Other 27s in here? No, yes. Oh yeah, network policy status, there we go.
So what happened with these host IPs? Because we went back and forth a lot of times with this.
On which one?
The field status.host IPs, just the one on the right, to the right.
I think it is. I lost. Oh, I think that's on me to go look at again. It's in the queue. It's in the queue of perpetual, like needs reading, but isn't as important as everything else in the queue.
Okay. Another column.
Yeah, right. Okay, so I think that's it for now. I'll run through the other ones to see if there's any that have making any progress or need to be moved out. This is the time where I remind people that if you have KEPs that aren't in this dashboard, we're not paying attention to them, or at least I'm not. So if you know of KEPs that aren't here, let me know and we can add them to this dashboard, or you can think you can assign them to the project yourselves. With that, I'll stop sharing and let you continue with the agenda.
Roger that. All right. Moving on to the next item then. Marcus, network quality of service demo and feedback. Go ahead.
Yes.
Tell us.
Yeah. Hello, everyone. I'm Markus Lehtonen, working for Intel. I've been mostly active in the SIG-Node side of Kubernetes, and I'm about to present KEP that I've been pushing to Kubernetes, and then kind of one possible user of that KEP, so kind of network quality of service. So I would have a few slides just to present, give some background overview of the KEP, and then I have a demo of a proof of concept,
Sure.
kind of network QoS implementation that we have based on the mechanism, or the KEP mechanism. And if you can give me the presenter rights, I could start with the few slides that I have. Not yet.
Go for it.
Yeah, thanks. So, do you see anything?
I see quality is, yep.
Yeah, cool. So yes, so I'm going to present this overview of the QoS resources KEP, and then kind of one usage of that we've been kind of concepting network QoS. So the QoS resources KEP is about improving the quality of service of applications in Kubernetes, and it's really the main kind of goal there is to improve quality of service applications by enabling like mechanisms and technologies, primarily for QoS, that have traditionally been out of control in Kubernetes. So like two primary usages for these that we could enable immediately with this KEP is cache allocation and memory bandwidth control. In Intel, we have this kind of hardware technology called resource director technology for RDT, and they are similar in AMD and ARM as well, but it's kind of in the hardware sort of class-based mechanism. And we also have implemented in the runtimes class-based management and configuration of the block IO C group controller for managing throttling and prioritization of local disk IO. So these would be the kind of immediate first kind of customers for the new QoS mechanism. But then there are other usages that we've been concepting and thinking about. One is network QoS, then there's like memory QoS, swap management, and other usages as well. There's the link for the PR for the KEP, and we are now really trying to get this into 128 as alpha. It has been on the table quite long in SIG-Node already. Originally it was tagged for 125, but then dropped because of reviewer bandwidth limitations, and same happened to 126, and we missed 127 as well. And now really trying to, well, get awareness for this KEP and people to kind of +1 and review it if they're interested, and then yeah, get feedback on that as well. So few kind of design principles of the KEP and principles. What we are trying to do is kind of, we're trying to add we call it, well, resource type in Kubernetes, so kind of fundamental new resource type like QoS resource, where you would not allocate any numerical amount of something, but just kind of assign a class identifier to a container or a pod. So the resource could be, yeah, in this case, network, and then you could just assign this network class, let's say fast, slow, or something else to containers. And then, so it's not exclusive allocation by design. So basically multiple containers can be assigned or pods to the same class. And one generic principle there is that we try to make it kind of simple, life simple for Kubernetes. So keep these as opaque to Kubernetes as possible. So the configuration and management of these QoS resources and classes would be handled in the container runtime or below that. And Kubernetes only kind of knows the resource types, let's say network or cache, and then the classes which are available on which nodes, but not much other than that. And really Kubernetes doesn't need to know the meaning of the resources or the classes or the kind of parameterization. So what, let's say, network class fast would mean. So Kubernetes doesn't need to know anything about that. And kind of short simplified architecture diagram of the KEP that we are proposing here just to get the understanding how it will or would play out in our proposal is that well, this simplified picture has like simplified Kubernetes cluster with API and scheduler from the control plane, and then one node, and in the node we kind of depicted kubelet, and then the container runtime, and then the system is everything else, OS and hardware and everything. And kind of the story of the QoS resources starts from the point or bullet 1 in this picture. So the container runtime would initialize or discover the QoS resources and classes available on the system, and then in the step number 2, it will or would kind of inform kubelet about the available QoS resources and the classes, and then in step 3, kubelet would in turn update the node status in the API server. So in this case, it would update or show 3 types of QoS resources in the node A, B, and C, and then some classes under each QoS resource type. And then in step 4, the pod is created in the API server. It has some requests, in this case 2 requests for 2 different QoS resources. For A, we would request class gold, and for C, this high priority class. And the scheduler picks that up and pod up and does the kind of normal node filtering and to see which node is able to satisfy the QoS resource requirements, and it sees that okay, node X, it can provide this gold class for A and high priority class for C, and then it schedules the pod to node X, and kubelet picks that up, it picks the pod up, and then in step 7 then sends the information to the container runtime that okay, create this pod and these containers, and with these QoS resources and classes, and then the runtime in the last step number 8 will actually enforce then the actual resource control mechanisms or QoS, whatever that means, then enforces that on the containers and the pod sandbox. So then about the network QoS proof of concept just one slide. So we thought that, okay, how could we, or how would it be possible to leverage this mechanism for network? And we came up with a one solution with, or yeah, proof of concept type of solution. We've had some private discussions with some people, and they've been kind of encouraging that, okay, looks kind of that it could work out, so please present it to SIG-Network, and that's what I'm now doing. So in this proof of concept, we kind of extend the CNI config in a sense to have one top level field. So utilize the CNI config and the capabilities mechanism to express QoS resources or the classes, and the runtime gets the QoS available classes from the CNI config, and it has this in this proof of concept this QoS field on the top level, and it can have arbitrary number of classes. In this example on the right, we have fast and slow, and then something else. And basically, you can define or specify any arbitrary, or could specify any arbitrary capabilities there. And then the runtime in our proof of concept, we have containerd now enabled. So it gets the network QoS class that is requested. It gets it from the kubelet at the sandbox creation time, and then just sees what capabilities are set for the class, and then passes those capabilities to the CNI plugins that kind of are willing to get those or understand the capabilities. And I think I'll switch over to the demo so you can see that in action, that what it really looks like in practice. So here I have a single one node cluster running patched Kubernetes. I haven't rebased the code in a while, so it's still like 1.27 alpha version. But anyway, and a patched containerd to support these QoS resources. The one node cluster, I can show how the node looks like. So we have some QoS resources here. For example, here for the network, we have now like 3 classes: fast, normal, and slow. And then we have like per node capacities there as well. So fast, there can only be 1 user on the node, and for normal network, we can have 8, and slow, like infinite number of users. And then we have some other QoS, this block.io and RDT as well, which block.io is local disk control, and RDT is this cache and memory bandwidth allocation. So that's how the node looks like. So then first simple example of a pod requesting some QoS resources. So here we have a simple pod doing really nothing but requesting like fast network, and then which has one container that requests this cache memory bandwidth plus gold, and block.io plus max priority. And then we run that pod, and we see that it's running, and then we can take a look at the node as well, and we see that okay, the capacity has changed. So network now it's kind of saturated. So fast has been saturated, and max priority block.io as well. So there are users for that. And then if we try to create a second pod, this also requests for fast network and some other resources, 2 containers. Then we schedule that one, and now we see what happens. Okay, it's pending, and kind of the scheduler knows what is the problem there. So no, it's not available, insufficient class fast for net, for example. And then if we delete the first pod, then we should get this second one running. So now it's running. So that's the kind of how the generic mechanism or the QoS mechanism looks from the user point of view. Then about this network QoS. So everything is specified in the CNI config. So this is my CNI config, simple, just bridge plugin, and then the bandwidth plugin for kind of demonstrating the QoS. So I have like specified here 3 classes: slow, some bandwidth parameters, then normal, it has capacity of 8 for this node, and then fast capacity 1, and then some bandwidth parameters. And as we saw, we have the same kind of classes and capacities on the node as well. And then we can also see that it actually does something. So when, okay, this simple pod requesting fast network. So let's run that one. And then let's see the what. Oh,
Demo
that's no,
guides.
0. Yeah, no, well, here, okay. So now we can see that. Let's wait. So now we can see that it kind of, for the Ethernet interface, it kind of actually put in the bandwidth parameters that we set, and then if we can get another one, this requests the class normal, then and then let's do the same grep operation. So now for the second one, we have like smaller bandwidth, and it's also kind of dynamic. So okay, let's see. Describe node, sorry. So okay, now we can see that there are like one user of normal and one user fast. So but it's dynamic. So if we just edit the CNI configuration, create a new class, let's say foobar, and put the capacity, let's say 4 users per node, and put some other parameters here. So no, it's not yet there. Okay, now we see that now the foobar class actually appeared on the node. And then if we, let's say, create a new pod where we actually request this foobar class. That's great. Container creating, yeah, and then let's do this grep. So okay, we can now see that okay, with this new interface we got the parameters that we
Cool.
got to pull. But yeah, this
Sorry, go ahead.
got to show. yeah, so any questions, comments? But I'm after that. Yeah, get feedback. How does this? Is it totally insane, or what do you think about with it?
I don't think it's totally insane. I appreciate you putting all this effort in to present and stuff today. We are running a little short on times, but no, it's okay. I
Sorry.
just wanted to kind of point out the time, but I have a couple of questions. So I'm personally, this is interesting. I'm personally coming in this late. I'm like, this wasn't really on my radar before, so I just CC'd myself on the PR. And this is probably an obnoxious question, but I just didn't catch this while looking anything over. Do you have other orgs that are kind of interested in this, working with you on it, or was it mostly just Intel so far? Just a question, just curious, because I didn't see a.
Well, yeah. So a lot of people have kind of, let's say, said that they're interested, and yeah, it looks like cool mechanism, but no kind of other industry partner that I could kind of
Gotcha.
give you at the moment that okay, we Intel and let's say some other big player are kind of driving for this, but this kind of tries to be a generic mechanism and to enable a lot of use cases, and there, yeah, in the CEP we list some and some more exotic possible future endeavors as well.
Gotcha. Lars just linked Celium's bandwidth manager, which I assume is like is to say, hey, this might be relevant to you as well.
And yeah, and one yeah, of course comment. So this of course needn't be kind of any like fast, normal, slow type of. It could be like red, blue type of. If you have a different kind of, well, you know the network better than me, but kind of have a fast backbone network for storage, and then like not that fast for services, and then you could kind of like select, okay, now I want red type of network, and then kind of scheduler would know automatically that okay, red networks are available on these nodes, and then if you have some multi-network plugin, Multus or something, you could kind of.
So this is the biggest problem I have, Marcus. I'm not ignoring you on Slack. I'm just super busy. I'm ignoring everybody. I'm not ignoring you in particular, but the problem that I see here is we have 3 now KEPs in flight that are all roughly describing overlapping areas, right? This is a explicitly qualitative API, not a quantitative API. You can't request 1 gigabit of network traffic. You can request gold or purple or triangle, right?
Yeah.
And there's the multi-network KEP, which is about indicating the need for explicit network connections, right? I need connectivity to this exact network. And there's the dynamic resources API, which is about connecting to specific arbitrary resources. We just had a conversation this morning about trying to bring those latter 2 in line. I had not been thinking about this one as part of the multi-network space, but now that you bring it up, I can see the potential for overlap. And so we need to figure that out. My biggest fear here, I love this idea, by the way, and as a qualitative metric, I've definitely heard customers over and over and over again asking for priority access to networking. So I like the idea. I'm just super concerned that we're throwing 3 huge things at the scheduling subsystem all at the same time.
Well, Tim, you mentioned what it's theoretically possible to bring the DRA and with multi-network CEP together. So hopefully it will be like one thing to the scheduler, and it's already like implemented problem. For this one, like according to what Marcus tried, it's not that big impact to the scheduler because it's like we're countable resources and the same like node status part, so should be not that problematic.
Yeah, I need to go back and catch up with everything you guys have done and give you some love soon. So I'm
Yeah,
I'm
but-
excited about it purely selfishly because I hear about people all the time who want their more important work to have more access to network.
So the reason why we thought about the QoS for like for this kind of network setup is it's more for like more formal parameter passing to existing setup or existing like thing like Multus. It might be more helpful rather than annotations. And for this multi-network interfaces with explicitly requesting the interface, yeah, we had also in our plans to talk with SIG-Network, multi-network folks. Unfortunately, we missed the meeting yesterday, but Antonio directed us what we will talk to them anyway. And for DRA, yes, we definitely want to have it as a like both container level and pod level resources, so the network abstraction can be done with the same approach what we did for devices.
So we do have a couple other agenda things. We should probably, if nobody else has got big questions, we should push ahead.
Yep, sounds like we are running low on time. It sounds like the next follow-up here is to kind of connect the dots between these three KEPs. Marcus, thank you for bringing this up. This was a great presentation. I also think it's really cool, but a little bit more of coordination, I think, sounds like is what we need to do next to keep you moving forward. All right, so that is poll enhancements number 3004, if you're interested. That's the PR. Please join in the conversation there. All right. Moving on. Dave, let me share my screen again. Next agenda item, Dave, endpoint slice type FQDN. Go ahead and start your.
Yeah, I guess the backstory here is Knative uses service type external name kind of like as a CNAME, a way to program CNAME records within the DNS system without actually needing to know what the DNS system is. Recently, with all the external name CVEs, which can cause confused deputies for proxies or turn proxies into confused deputies, it sort of suggested like don't use or external name references, especially having proxies and programming them to point to these type of services. So I kind of discovered like, hey, you could use endpoint slices, and then the specific type is the fully qualified domain name as like an alternative to get CNAME records into the Kubernetes DNS system. And lo and behold, I saw it was being deprecated because there were no defined semantics. So I kind of chimed in on the issue, suggesting like, hey, hold on, let's not deprecate it. I have a potential use. Whether this is the way to do those sort of record aliases or an alternative, I'm just trying to come here to figure out like what's a good path forward. Because one of the reasons why this came top of mind for me is for the Gateway API, one of the issues is having conformance on the different types of Kubernetes services that can be potentially targeted as a backend. So it'd be good to know, like, hey, this isn't a valid type anymore. Don't include that in the upstream test, conformance test. And alternatively, for me in the Knative sense, like, how do I, as a person writing or targeting Kubernetes as like the platform for these higher level CRDs that we have, how do I program the DNS? That way, I can program gateways to point to these services that are, I would consider, managed only solely by Knative and not end users. So that's sort of like, I hope to summarize the discussion that's kind of happened in this issue. And thanks, Tim, for asking questions. It'd be easier if I could just be with you to whiteboard it.
Yeah. I had to go and I apologize for losing track of this thread. I had to go and reread all the context of it, and I remember now. So for the larger audience, the history here is if you allow a shared proxy to access services in the cluster, like an ingress gateway or something, and you allow an individual like namespace A to request the proxy to serve namespace B, right? Then you have enabled a way to get access to things that you might not have access to, but the proxy does. And in particular, you know, the user in namespace B might have configured the proxy to have firewall rules, right, at that point. And they may have their own network policies that prevent you from, in A, from accessing it. But by going through the proxy, you've now enabled access to something that you shouldn't have enabled access to. And so that was the big CVE. That's why we shut down or tried to shut down all the external name support. Like people, you shouldn't be doing that. External name is just a way to get around that. It's why Ingress doesn't have a namespace field on the service. And it's why reference grant exists in the Gateway API, right? So the question then is, is there a legitimate use case for wanting A to be able to export an endpoint that is in B? And it sounds like Knative has a use case for that. And then how do we do that in a safe way that doesn't enable the escapes that you don't want? And there's a follow-up of how do I enable routing to arbitrary DNS names that aren't necessarily cluster services without also enabling routing to cluster services. That's sort of where the thread ended, right?
Yeah, and I can highlight Knative's use case for those on the call. We do a bunch of fancy stuff like L7 traffic manipulation, like splitting and rollouts and things like that. And we also want it to be done within the cluster, like for potentially like one Knative, I'll just call it application in namespace A, wants to call a Knative application in namespace B. But there might be traffic splitting. So what do we do there? We actually will proxy you through an L7 proxy that might exist in a Contour namespace or an Istio namespace. So that's why we use those sort of aliases to support that extra hop, so we can do these sort of fancy traffic manipulation. But I would say everything you mentioned is accurate. Yeah.
And fundamentally, it comes down to, I have a shared proxy which has different trust domains. How do I somewhere denote that this is okay and that's not okay?
I'm trying to think of how we could use reference grant for this.
I think the other thing to note is like Knative does a lot of programming mechanically or programmatically. So like if it involves like a third person to come in, as long as like we can do it programmatically, I think that's fine. And as long as it's a because someone's suggesting like, oh, can you just program core DNS directly? And I'm like, no, because I don't want, unless there's a proper Kubernetes API that is portable, then I don't want to do things like that. Maybe Cloud Run can do that.
As absurd as that sounds, I feel like that may be an easier path. You know, it seems like we keep on getting stuck on this is something like I can see the purpose of, but it's also very hard to do safely. But certainly something that we've been thinking about, or I've been thinking about, is if we're ever going to have cluster IP gateways and we want to have a similar experience to service, then we need cluster IP allocation, which Antonio's gets us close to. And then probably some way to allocate DNS names. So maybe that's actually a more promising path. I don't know.
Yeah, I think my purpose of coming here is for there to be a path. I don't care if this takes like 2 years or whatever, because I know in the meantime I can
Be
just like
careful.
I can like shim in like one service's like cluster IP into the other's endpoint, right? Like that, like I have a workaround, which isn't ideal. But we already have to do that for Contour because they completely turned off external name support, like Istio chugging along, which is great. So I'd rather, yeah, like to your point, Rob, like it would be nice to do it right. And if I can, for example, create like DNS records at a higher level API, that'd be great.
And I think the problem here is that, I mean, I agree with Rob that that seems like a likely outcome. But there's a chain of questions that we need to answer before we can get there. Like the service IP stuff is still sort of under discussion about, I don't know if we're talking about it today, but there's a big open issue of how it overlaps with the pod cider allocations. And literally I use the word overlap on purpose because that's sort of the core of the problem. And like, I don't know that we can really decide on what we're going to do with DNS resource until we have a clearer picture of what we're doing with the service IP allocation. And I desperately want service IP gateways, right? And Rob knows this. I never shut up about it. Yeah, I like in the thread we discussed, maybe there's an alias kind of service, and that's a way to use reference grant. I don't really know how that would work. I just was spitballing. You know, what I'd like us to encourage is, let's think about some creative answers instead of just trying to shoehorn in the things that we know don't work, but paint off the corner cases, right? If we can find a different way of representing it, if we can get to the core problem statement, how do I denote that something is safe and something else is not? Maybe we can find a different way of approaching it. In fact, I'm going to bring that thread back to my mailbox because I lost it. Anybody else wants to chime in?
Sounds like a tough one, but yeah, we can help keep you moving forward.
Another extreme, I guess, I haven't thought about it, is if like this is sort of like a hack, really. Like, could there be a designated label Gateway API recognizes as like, if this label exists on these services with external name, then we know we can trust this. I don't know if, and then that could be like, for example, an operator can create a webhook that prevents that service with those labels in generic namespaces, but allows it in some places. Or I assume also the webhook can look at the role of the user, potentially.
Yeah, I mean, it's really tough. This is
Yeah.
this is an authorization problem, you know.
That one's gonna
I can't remember who else mentioned it, but you know, reference grant as it gets into SIG-Auth and moves more and more to authorization is also a possible solution here. But I don't know. But you know, any kind of label or something that it feels like is really just kind of a hack or a workaround.
Yeah, that's fair. I guess, can reference grant express like would it express the traffic being able to go from one to another namespace, or are you trying to say the reference grant would allow users to create resources of a certain type?
At this point, the idea in SIG-Auth is that reference grant would allow cross namespace references, you know, as today, but also authorize them so the controller can read those resources across namespaces without having, you know, full access.
This was my upcoming topic for the meeting.
Yeah. Okay. So that's probably a good transition. I know we're
Cool.
near time here. So
No, that's okay. I'm just letting you know, like I had intended to bring this up too. So there's a little bit of this in a doc that you'll be able to see, David.
Awesome.
It's on the meeting agenda.
Yeah, that's all I had. Thanks,
Okay.
everyone.
Thanks for bringing it back. I popped it to the top of my queue again, and I will try to put some more thinking into it. But just to repeat myself, like, hey, people, put on your creative thinking hats. Let's try to see if there's another angle to come at this from.
And if you feel the back and forth on the issue is like, if you just want me to whiteboard, like on Miro, just ping me on Slack. I think
You
I'm
got
just deep tasso to save us time. I'm available.
Roger that. Okay, thank you, Dave. So I just had this relevant little tidbit. This document, which I linked in the notes, is a Scratch doc. Rob, Nick, and myself all met with Jordan Liggett, the SIG-Auth guys, and basically talked about the future of where reference grant would go, which you can look in here at some of the notes. It's fairly long, but to summarize, there seems to be interest in kind of, there's like a dichotomy now where on one hand, our reference grant and gateway API is about basically allowing network access to endpoints. But they are interested in having the in-tree reference grant, which we're kind of perspective about right now, more or less being a tool to where there would be a controller that would actually like provide the RBAC permissions relevant to that and like give them to an entity. So that's kind of the direction that they're talking about right now. And I wanted to bring this up because reference grant was, born here in SIG-Network. It's starting to hit multiple SIGs. And if you're at all interested, I would track this, get in touch with Jordan, and basically it's SIG-Auth, SIG-Network, and SIG Storage who's implementing reference grant right now. So if you're interested at all, if you want to help contribute to that implementation, just wanted to raise this for people to see kind of where that was going. And Rob, if you have anything that you want to add on top of that.
Yeah, I mean, just this is a huge set of projects here, so there is lots of opportunity to help out. If this is something you want to see succeed, we're going to need some help. So there's a series of things that we want to get in here, including custom authorizer. So again, just this is really just this will happen eventually, but it would happen sooner if we had more people to help. So.
Careful what you ask for. Yeah, I mean, I'm watching it, trying not to get super involved because I don't think I have anything unique to offer. But what I'm seeing really is Kubernetes as a project is maturing in regards to permissions and security. Still, this feels like you've opened a can of worms that is actually lot more worms in there than you thought. We are now entering a space where, yeah, we really do need this, but what we need is sort of an order of magnitude more sophisticated than what we needed for Gateway, which is great. It's unfortunate that it will slow things down, but I think it's great that the larger auth folks are now looking at it.
Yeah, interesting metaphor. I would have not gone for can of worms. I would have been like box full of cats, but you had no idea the cats were in there. It's like this is going to get very, very interesting, and just the future of potentially having APIs where it's like, I do this, it can get an entity and like provide it with RBAC is enormous. So yeah, definitely jump into the conversation if you want to do that. The SIG-Auth meetings are probably, wouldn't you say the SIG-Auth meetings are kind of going to be the center point for this going forward, Rob?
Yeah, I think so.
Yeah.
There's going to be a lot of work in the next, we're getting into the next KEP and enhancement cycle, and that's going to be where a lot of this discussion has to happen. I think we've agreed on a general plan, and so I'm hoping we can get the KEP finalized this cycle, but there's a lot of work that KEP will require.
Yeah.
Roger that.
Shen,
So
I see.
go ahead. I have a hard stop at the top of the hour for a very important meeting, so I just wanted to point that out. So if you guys want to take it beyond normal, but we're at the last minute here. Go ahead, Dave.
Oh, we're not very important, Shane. Thanks.
You are. That's why I'm here. But I have to get to that next one.
No, I think it's good that we stop pretty much on time. Anybody last words?
I can ping you on Slack about my question.
Yeah, I take the two IPVS issues.
Thank you, Lars.
Yeah, thank you very much, Lars. Appreciate that. All right. Until next time, everybody. See you in the Slack.
Take care.